In the midst of war, while the sound of gunfire echoed across battlefields, there was another battle being fought, one of calculation of code of numbers. This was a battle that took place in the quiet of laboratories behind walls of secrecy, with the fate of the world hanging not on bullets, but on binary. It was a war not fought with weapons, but with machines. Machines that could think machines, that could compute machines, that could crack the very codes that once seemed unbreakable. The dawn of the computer age had arrived, but it was not one of sleek, shiny screens. It was a world of gears, wires, and electricity, a world where the first computers were born out of the darkest corners of war. It began with a single word: enigma. The Nazis had created the ultimate code machine, the Enigma machine, so complex, so cryptic, that the best minds in the world believed it could never be broken. But hidden away in Britain at Bletchley Park, a different kind of battle was being fought where one man, Alan Turing, was working tirelessly to crack the code. His answer wasn't just a new method of thinking, it was a machine that could think itself. The bomb. The first electromechanical device capable of breaking the Nazi ciphers had been born. But Turing's bomb was just the beginning. It was a precursor to something greater, the first steps towards a future where machines could solve problems faster than humans ever could. In a world where every minute counted, where breaking a code meant saving thousands of lives, the bomb was a game changer. But it was crude slow by today's standards and designed for one thing: breaking a single code. To truly change the world, Turing and others knew that the real revolution would come when computers could perform any task, not just solve one problem. Across the English Channel in Nazi-occupied France, the same war was unfolding, but in the shadows hidden from the public. The Nazis had their own ambitions to build machines of war, but their vision wasn't just limited to tanks or planes. The Reich wanted to build machines that could decode the mysteries of the universe. They began developing a different kind of machine, a machine that would perform calculations faster than the human mind could fathom. Meanwhile, in America, a group of engineers was working on a different kind of machine, one that could not only break codes, but could carry out any calculation in the world. In the heart of Pennsylvania, at the University of Pennsylvania's Moore School of Electrical Engineering, a team led by John Presper Eckert and John W. Mauchly was building what would become ENIAC, the Electronic Numerical Integrator and Computer, the first general-purpose digital computer. It wasn't much to look at. In fact, it was massive, filling an entire room with thousands of vacuum tubes flickering like the pulses of electricity running through them. ENIAC was a behemoth weighing over 30 tons, occupying 1,800 square feet, and using 17 468 vacuum tubes. It consumed more power than the average home would use in a year. Yet for all its size, it was capable of performing 5,000 calculations per second. To put it simply, it was the world's first true electronic computer. But ENIAC wasn't just a marvel of engineering, it was a weapon of war. Built to calculate artillery firing tables for the U.S. Army, it had the potential to save lives by making calculations faster and more accurate than ever before. In the middle of World War II, with a global crisis unfolding, ENIAC was the brainchild of military necessity. But its significance stretched far beyond the war effort. What ENIAC proved was that machines, giant, powerful, and precise machines, could process information in ways that no human mind ever could. Meanwhile, in Britain at Bletchley Park, Turing's bomb was doing its job. But there was still a feeling that something bigger was needed to match the Nazis' ever-evolving ciphers. Turing, who had created the bomb, continued to push for something even more advanced. The bomb had helped break Enigma, but it was not a universal tool. It could only solve one type of problem. Turing's vision was of a machine that could adapt, think, and learn, a Turing machine that could process any form of information, solve any problem. But Turing was not the only one dreaming of machines that could think. Across the Atlantic, ENIAC was being constructed. And with it, the future of computation was beginning to take shape. In the wake of ENIAC's completion, the world was about to step into a new era, one where the true potential of computing beyond solving military problems would be realized. The world saw the power of these machines, but it didn't yet know the depth of their potential. As ENIAC hummed to life, its engineers saw the first signs of a new era, one where the boundaries of human intellect were no longer constrained by the limits of human calculation. Soon, computers would not just aid the military, they would revolutionize every field of science, business, and life. For now, however, these early computers were more about solving the complex problems of war. For Turing ENIAC and all those working on the frontier of technology, the end of the war didn't mean the end of their work. It meant that the digital revolution had begun, one where machines would learn, think, and calculate, but not just for war. These machines would become the foundations of a new world. After the war ended, ENIAC's legacy didn't fade with the retreat of the Axis. Instead, it paved the way for a future that no one could have predicted. Soon, universities and businesses began to develop smaller versions of ENIAC, the next generation of computers, designed to be more accessible and less reliant on vacuum tubes. And then came the mainframe computers that were smaller, faster, and more powerful, able to perform a variety of tasks far beyond the needs of military calculations. Turing's bomb and ENIAC had laid the foundation for a new world where machines would process the endless flow of data, transforming not only warfare but society itself. As ENIAC's creators turned their attention to more practical uses for the machine, the world began to see that the future of computation was not just about breaking codes or calculating artillery trajectories. It was about shaping a new world where information could be processed at speeds and scales previously unimaginable. Today, when we talk about the digital revolution, we look at the computers we use every day, the devices in our pockets, the servers that store our data, the networks that connect us. But all of this, everything began with Colossus and ENIAC, the first machines that not only calculated but set the stage for the digital age. They were clunky, noisy, inefficient, and gigantic by today's standards, but they were the pioneers. From Turing's bomb to ENIAC circuits, the world had entered the age of information processing, and the battlefield had been reshaped by the digital revolution. The legacy of ENIAC, Turing, and the early computers is one of thinking machines that would in time change everything. They were not just machines for solving equations, but machines for reshaping the world. And so as the war came to an end, the era of computation began. It wasn't just the end of World War II that marked the shift. It was the dawn of a new war, the war for knowledge, for information, and for the future of humanity itself. In this war, the machines would win, and they would change the world forever.